Hello everyone, I am Disha from Sri Venkateshwara College of Engineering. This video is about the topic pointer aliasing. Let us know few points about the pointer first. Pointer is a variable that stores the address of another variable. Unlike other variables that hold the value of a certain type, pointer holds the address of a variable. Advantages of the pointers are pointer provide direct access to the memory. Pointer provide a way to return more than one value to the function. Pointer provide an alternative way to access array elements. Pointer reduces the storage space and complexity of the program. Pointer reduces the execution time of the program. What is aliasing? An alias occurs when different variables point directly or indirectly to a single area of storage. Aliasing refers to the assumption made during optimization about which variable can point to or occupy the same storage area. Pointer aliasing. When a function has two pointers with the same value, we say pointer alias each other. Pointer aliasing refers to the situation where the same memory location can be accessed using the different pointer names. The strict aliasing rule in C or C++ means that pointers are assumed not to alias if they point to the fundamentally different types. Aliasing introduces strong constraint on program execution order. The following are the example for the aliasing of P and Q variables. The following is an example for pointer aliasing in which both pointers P and Q point to the same address. The assembly language code produced by the compiler is an example, and it's shown in the middle column, and the operations and the clock cycles are in the right side of the slide shown here. Consider a simple example here. In this case, pointers A and B point to the distinct memory blocks. This code is perfectly parallelizable. Memory dependencies. Memory dependencies in the code can limit the kinds of optimizations attempted by the compiler. For example, in the following code, x, y, z and a pointer p and q might be unrelated. However, within the function code, both pointer p and pointer q point to the same global variable xyz. The compiler must guarantee the correct execution under both these conditions. Due to these conditions of memory dependencies, the compiler needs to be conservative and limit optimizations. Strict aliasing rule. The strict aliasing rule dictates that pointers are assumed not to alias if they point to fundamentally different types, except for character pointer and void pointer, which can alias to any other data type. This is shown in the following graphic, which shows the universes and associated pointers. Pointers are associated with the type universe U. T is a template, and in preceding graphic, the various templates are shown, including an int universe and a float universe. There is also a my-class universe per design. Additionally, there is a character universe that includes all universes by default. Universes do not alias. Pointer P can only point to any address within the int universe, whereas pointer Q can only point to any address within the float universe. Because of this, pointer P and pointer Q cannot be aliased. Derived pointers point to the original universe. Pointer derived from a restrict pointer are considered restrict pointer and point to the same restricted memory region. Character pointer use universe contain all the universes. A pointer can point to any variable in all the universes that are only the character pointers. For two pointers for the same type as in the following, where both p and q are int, the compiler is conservative and aliasing is applied, resulting in loss of performance. Here is an example for the loss of performance. Restrict keyword. The restrict keyword is mainly used in pointer declarations as a type qualifier for pointers. It does not add any new functionality. It allows you to tell the compiler about a potential optimization. Using restrict with a pointer informs the compiler that the pointer is the only way to access the object pointed at, and the compiler does not need to perform any additional vectorization concept using pointer aliasing. Pointer aliasing is a hidden kind of data dependency that can occur in C, C++, or any other language that uses pointers for array address in arithmetic array data identified by pointer in C can overlap because the C language puts very few restriction on pointers. Two seemingly different pointers may point to storage locations in same array. As a result, data dependencies can arise when performing loop-based computations using pointers, as the pointer may potentially point to overlapping regions in memory. However, vectorization takes place, compiler needs to provide or prove to itself that no data dependencies are possible. This is difficult to do when using pointers, which means that compiler is often forced to be conservative about vectorization. Fortran 9095 is less vulnerable to this issue because a pointer must explicitly associated to a target variable of known size before it can be used. The summary of this video: if a function has two pointer pa and pb with the same value, we say the pointers alias each other. This introduces constraints on order of instruction execution. If two write access that alias occur in program order, they must happen in same order on processor and cannot be reordered. This is also the case for a write followed by a read or a read followed by a write. Two read access to alias are safe to reorder because any pointer could alias any other pointer in C. The compiler must assume that memory regions accessed through these pointers can overlap, which prevents many possible optimizations. Proper use of restrict keyword in AI engine kernel programming can result in performance gain and eliminate undefined behaviors in your code. However, be aware that when assigned to the same scope, the restrict pointers might result in undefined behavior in your design. Thank you for watching this video. Please do like, share and subscribe.